Welcome back to Algebra 1 with Miss Betsy. This is part 2 of the video where we are learning to use the method of completing the square to solve quadratic equations. I started this and ran out of time, so I want this to be the conclusion to this lesson. What I'm using for my text looks like this. This is the second edition of Algebra 1 for Christian schools. And it's published by Bob Jones University Press. So let's say, I want to look at page 457 in that text for my co-op class. If you look down there at the bottom, there are 5 steps that tell you the methods, the steps that you need to go through to solve equations by completing the square. So let's say that we had this particular problem before us. We have x squared plus 6x plus 5 is equal to 0. And if you look at your text, it says first rearrange terms so that the constant is on one side of the equation and all the terms containing variables are on the other side of the equation. Now this is different, remember, from when you are solving quadratic equations by factoring. Because when you solve quadratic equations by factoring, this is what you want your equation to look like. You want to have everything on one side of the equation set equal to 0. However, we're not going to solve this equation by factoring. Even though we could, it would be x plus 1 times x plus 5 is equal to 0. So it's going to be x is equal to negative 1, x is negative 5. But we're going to use this as an example of how we step through the process of completing the square. So we want to have all of the terms that contain variables on one side of the equation. That's typically going to be on your left-hand side. And you have the constant terms on the right-hand side of the equation. Now the second step says complete the square on the side containing the variable, making sure the same operation is performed on both sides of the equation. In other words, we have to make sure that we keep our equation in balance. So how do we know what to add to this binomial over here to force it to become a perfect square trinomial? Take this coefficient, the absolute value of it, we divide it by 2, we take half of it, which would be 3, and then we square that. So half of 6 is 3, 3 squared is 9, and then we add that quantity of 9 to both sides of the equation. Make sure that you don't just do x squared plus 6x plus 9 is equal to negative 5, because then your equation's out of balance. You must make sure that you add a positive 9 to both sides of the equation, and then you just go ahead and finish solving this equation. We now have a perfect square trinomial that factors into x plus 3, the quantity squared. And if you do not know how to factor perfect square trinomials, as I said in the last video, you have to learn or you will not be able to complete the square. Quantity x plus 3 squared is equal to 4. Now we can use the method of taking the square root of both sides of the equation. When we take the square root of both sides of the equation, let me just go ahead and write this unnecessary extra step here, becomes plus or minus the square root of 4. Square root of x plus 3, quantity squared, is simply x plus 3 is equal to plus or minus 2. We don't care what x plus 3 is equal to. We want to solve for x. We subtract 3 from both sides of the equation. We see that x is equal to negative 3 plus or minus 2. Means that x is equal to negative 3 plus 2 is a negative 1, or Negative 3 minus 2, x is a negative 5. So x is equal to negative 1 or x is equal to negative 5. And if we use set builder notation, it's going to look like this. The solution set that contains these two elements, negative 1 and negative 5. So that's the methodology, the process that you're going to use to complete the square, to solve a quadratic equation. Now, let's go ahead and do one final example here. That was very graceful, wasn't it? Okay, we have a squared minus 7a minus 3 that we want to solve by completing the square. A squared minus 7a minus 3 is equal to 0. You can't factor this. You can't use the property of the principle of taking the square root of both sides of the equation. So we're going to have to solve this at this point by completing the square. So we want to move all of the terms containing variables to one side of the equation and the constant term to the other side of the equation. We complete the square by taking half the absolute value of this coefficient. Half of negative 7/2 is a positive 7/2. And then we need to go ahead and square that. 7/2 squared is 49 over 4. So when we complete the square, I thought that was the brown. When we complete the square, we have a squared minus 7a plus 49 over 4. And again, you have to keep this equation in balance and make sure that you add 49 over 4 to both sides of that equation. This now looks pretty weird, but it's a perfect square trinomial. The middle term is negative, so when we factor the perfect square trinomial, what we end up with is x minus 7/2 quantity squared is equal to what? Well, 3 plus 49 over 4. You rewrite this with a denominator of 4. This becomes 12 fourths plus 49 fourths. You have 61 over 4. Now we can solve this equation by taking the square root of both sides. Rather than rewrite this problem, I'm just going to say that the square root of x minus 7/2 squared is equal to plus or minus the square root of 61 over 4. So, square root of 61, 61 I believe is prime. 4, however, is a perfect square. We take the square root of x minus 7/2 squared. We have x minus 7/2 is equal to plus or minus the square root of 61 over 2. So it's looking messy, but that's what algebra is. Sometimes it just looks messy. The more you practice with it, the more familiar you get with working with radical expressions, the more it's going to look normal to you. X minus 7/2 is equal to plus or minus the square root of 61. There are no perfect squares hidden in there. Over 2. We don't care about x minus 7/2. We only care about x. So to eliminate this negative 7/2 on the left side of the equation, we add a positive 7/2 to both sides of that equation. You end up with x is equal to 7/2 plus or minus the square root of 61 over 2. Now, you're getting pretty close there, aren't you? You think, oh, well, surely I'm done. Okay? We have a common denominator, don't we? When the denominators are the same, you add the numerators. So x is equal to 7 plus or minus the square root of 61. All of that is over 2. Now, if they had asked you to write this as a solution set, let me show you what you would do. I'm perfectly content with this answer. This is exact and it's complete. A solution set uses set builder notation. It has the braces, and you have the two solutions for this. 7 plus the square root of 61 over 2 is one solution. 7 minus the square root of 61 over 2. And then the other way that you could possibly show the solution to this problem would be with an approximation where you're using your calculator. You're not going to give an approximation unless you have one of two things going on. Either you're specifically asked to give an approximation, or in the real world you need to have an actual measurement that is meaningful. This is not, I can't translate that into inches or feet or miles or pounds. So you would use your calculator to come up with an approximation of what this answer is. That now is the end of section 11.4. See, aren't you glad it was so much shorter than part 1? If you have problems, send me a text and I'll see what I can do to help you.